In these absolutely massive refineries and petrochemical plants, there's this invisible world of rules. And these aren't just suggestions. We're talking about battle-tested codes that literally mean the difference between everything running smoothly and a total disaster. They're forged from decades of real-world experience. So today, we're going to dive deep into this hidden world and get to know two of the most important rulebooks in the entire industry.
So just picture a refinery for a second. It's like a sprawling city of steel, right? Processing thousands and thousands of barrels of oil every single day. What do you think is the one critical piece of gear that's controlling all that immense energy flowing through its veins?
It's this thing right here, the shell and tube heat exchanger. I know it might not look like much, but this is the absolute workhorse. It's the unsung hero that manages incredible temperatures and pressures, and it's what makes our modern world possible. And how you build one of these? Well, that's where our story really gets interesting. See, when you build one, you have to follow a standard. But here's the thing. Not all standards are created equal. What we're really looking at is a tale of two completely different philosophies. It's a classic showdown, the generalist versus the specialist. So on one side, you've got TEMA, the Tubular Exchanger Manufacturers Association. Think of it as the generalist. It's a fantastic, super widely used standard that has different classes for all sorts of different jobs. But on the other side, you've got API 660. This is the specialist. It was written specifically for the brutal, punishing environment of petroleum refineries. It's not just theory, it's a rulebook written from hard-won experience.
And this, right here, is the absolute key. The source material we're looking at really hammers this home. API 660's rules aren't just some arbitrary engineering calculations pulled out of a textbook. No way. They are lessons learned, often the hard way, from decades of running these massive facilities. It's a standard built on a foundation of what works, and maybe even more importantly, what breaks. Okay, so let's get into the specifics. How does all that past experience actually translate into the hardware? Well, the first and maybe most obvious difference is in the rules for just pure raw strength.
Let's start with the very heart of the exchanger, the tubes. I mean, just look at this table. The difference is, it's stark. API 660 mandates a minimum tube diameter of just over 19 millimeters. That's 3/4 of an inch. But TEMA, well, for certain applications, it allows tubes as small as 6.4 millimeters. We're talking about a nearly threefold difference in size. A thicker tube means more rigidity, way better resistance to vibration, and just a fundamentally tougher piece of equipment. API 660 is basically shouting, hey, in a refinery, there is absolutely no room for flimsy. And it's not just about the strength on day one, it's about longevity. API 660 actually forces engineers to plan for corrosion on critical internal parts. For instance, it makes you add extra material to things like the floating head backing device. It even connects the thickness of the internal baffles to how much they're expected to corrode over time. TEMA doesn't demand that level of future-proofing. API 660 is designed for a long, hard life.
Okay, so this focus on being tough leads us right to our next big area, performance. I mean, strength is one thing, but how do these standards make sure the exchanger actually does its job efficiently and reliably, day after day, year after year?
Well, the answer is all in the tiny details. Because when you're dealing with high-stakes engineering, the smallest oversights can lead to a ton of wasted energy or, something much, much worse, like catastrophic failures.
This is a perfect example. Fluids are kind of lazy. They always take the path of least resistance. Inside one of these exchangers, that can create what's called a bypass, where the fluid just flows around the tubes instead of doing its job and transferring heat. So API 660 mandates specific parts, like seal strips, to block those paths and force every drop of fluid to work for maximum efficiency. TEMA pretty much leaves it open.
And the level of detail here is what's really important. API 660 straight up bans certain designs, like perforated impingement plates, because it knows those little holes can create high-velocity jets that can literally shred the tubes over time. It also has super specific rules for things like thin-walled expansion joints to make sure they handle thermal stress safely. And again, these are the kinds of nitty-gritty details that TEMA either allows or just doesn't cover.
So we've got stronger parts and smarter designs from API 660. But how do you make sure it all actually gets put together correctly? That brings us to our final big area, the price of precision, which is all enforced during the fabrication process.
So during the actual building phase, API 660 throws in several extra layers of quality control. It's not just about what's on the blueprint, it's about the execution. We're talking about everything from demanding special close-fit holes for a tighter seal, to much stricter checks on the shell's roundness, to required heat treatments after welding, and even extra pneumatic leak tests. Each one of these steps adds time and money, but they all add up to a much higher level of confidence in the final product.
Let's just zoom in on one of those. Post-weld heat treatment, or PWHT. When you weld these huge pieces of steel together, you actually build up a ton of stress in the metal. PWHT is basically like a controlled spa day for the steel. You heat it up and cool it down really slowly to let all that stress just relax. This makes the final part significantly stronger and way less likely to crack. And you guessed it, API 660 makes it mandatory in critical areas where TEMA doesn't. So, after all these details, what's the big picture here? Well, it all boils down to a really fundamental engineering choice, the trade-off between cost and consequence. Let's be super clear about this. Building to the API 660 standard is more expensive. The source material is very direct about it. Thicker materials, extra parts, more testing, all of that has a real impact on the bottom line and the project schedule. There's just no getting around that fact. So at the end of the day, API 660 is the stricter, more detailed standard for a reason. It's built on a massive library of real-world knowledge from the refinery industry. And yeah, that means a higher cost up front. But as you can see, what you're really trading that cost for is a heat exchanger that is fundamentally safer, more efficient, and way more reliable over its entire lifespan. And that really leaves us with one final big question. TEMA is an excellent standard. It produces perfectly good equipment for countless applications, no doubt about it. But in the most critical systems where failure is simply not an option, where do you draw that line between something that's just good enough and something that is truly built to last?